Hello and welcome to the first session about Micronaut 4. I'm planning to do a series of small tutorials that will introduce you to Micronaut and give you dedicated insights on how to achieve certain things with Micronaut. Today we're gonna create a very simple REST API using Micronaut serialization. Micronaut serialization has the benefit that it does not rely on Java reflection, and therefore it's much faster and doesn't do anything at runtime reflection-wise. And yeah, hey, let's jump into this. And as always, to begin with a Micronaut project, I recommend to start on using Micronaut Launch. Micronaut Launch gives you a tool that you can easily jumpstart your Micronaut application. So as mentioned, I want to start a REST API using Micronaut 4. At the current time, 4.1.6 is the latest version, so we're going to pick this one. Then we use the latest supported Java version, which is 17. Fully aware that there is already 21 available, but let's use the one here. Then we're going to use Gradle. I'm a Gradle guy, so I use Gradle Kotlin. So it's statically typed build script, so we don't have it run into any problems in the IDE. We have better refactoring support and so on. And in this intro, we use JUnit 5 to create our tests. As mentioned, for the serialization, I want to use Jackson. So we can simply pick this feature here. And if we then jump into the preview mode and inspect our build Gradle, we can see that the dependency has been assigned to our Gradle build file. Okay, so in order to get started locally on your machine, you can then generate the project. You have different possibilities here. You can directly push this stuff to your own GitHub repo. You can download the application as a zip file, or my preferred variant here is to use a command. I have the Micronaut CLI installed on my machine, but if you haven't, you can simply use this curl command. But for now, I'm gonna use this Micronaut CLI command and jump into my terminal. So in this terminal, we can simply paste it. Here we go. You see, it now created a Micronaut starter application. It's based on Gradle 6.4, and maybe we can upgrade to the latest Gradle wrapper version. That's it. So for now, we're gonna start this in IntelliJ and wrong window. Let me just quickly move that one over here. As you can see, we now have a blank scaffold of our Micronaut application. Let me just, let's do a quick sightseeing here. So what we've got in this application. So we simply have an application class that contains the main method. Oh, damn it. So it's now complaining about SDK. Why is it doing that? Sorry about that. Here we go. It contains an application class with the main method, so we can simply run the application. And by default, it runs on port 8080. That's it. In the resource folder, we have our log configuration file. Micronaut uses Logback as a logger framework, and we have simple application properties where we can put our configuration into it. If you prefer YAML over application properties, you need to add in your starter project also the YAML support, because in Micronaut 4 this is not anymore built in. So what it then does, it provides a runtime library dependency with snake YAML, and you can use, as you can see here, application YAML instead of the properties. But if you write simple applications, you probably won't need YAML anyway. Okay, so today I mentioned we're gonna implement small REST API. Let's go with a simple resource. Let's pretend we have an API for a bank account. So we simply have a resource called account, and this is exposed, and we can actually read all the accounts. We can read a dedicated account. We can create a new account, and let's say we can delete an account. So just to keep the things simple, the account won't be any... It will be an easy thing, just for the sake of this presentation. So our account has a UUID, it has an account number, and it has a balance. So in order to work with monetary amounts, I tend to use a library called Java Money. This is a Java specification request, and it's very useful to work with monetary amounts. So I add an additional dependency here to my Gradle build file. It's called Moneta. It's actually the Java Money core reference implementation, and this one allows me to work with so-called monet. Dude, what's wrong? Yeah, here we go. And this is a balance. So let's import this one. Monetary amount has a currency and the value, which is a big decimal. And in order to access now this account, we need to create a controller. Let's create one and call it account controller. Let's expose this controller on the following path, /accounts. And in order to expose it, we use a collection of accounts. List accounts. Okay. Return. We don't have a database here, so I'm going to create a simple map that simulates the database. I put the key as an ID and the account as the value. Account store, like new concurrent hash map. So it's Bradlave, and we simply return all the values. In order to make this thing work, we have to expose it as a get. And now let's start with the fun part and start the application. I'm working with IntelliJ, as you probably have noticed, and IntelliJ has a nice feature with a small HTTP client, and I'm going to use it now to access the API. As you can see, it supports me. It already knows about the account path, and if I now trigger this request, I expect an error. No, why is that? It's empty. That's super strange. Let's implement. Because the list is empty, there is no error. The error I mentioned starts happening if we put an account into this storage here, and of course they need to have the same ID. So if I put ID and the number is like just say they have a strange thing, and the balance initially is 0 Swiss francs, for example. Okay. So if I then restart the application, now I expect an error to happen. Bam. As you can see, we get an error here because now the storage wants to return an instance of an account. And yeah, this Micronaut doesn't allow in Micronaut 4, which is very nice because it's more secure here. Micronaut requires you to state what types you actually want to serialize. So turning a Java instance into JSON. Our record doesn't state anything, so at this point to fix it, we have to work with this certable annotation, and with this annotation I actually say this account type is now serializable. And if we restart the application and re-trigger the request, we FFS. Now we have a different issue. We have the money thing. Our custom money class can't be serialized because well, this type is unknown, so we have to create our custom serializable. And this is a type I all prepared because I wanna keep this flowing. So let me quickly explain what you can do. Here is the monetary amount, serializer and deserializer. Micronaut defines this cert interface, which is typed. So you can say, hey, this is cert for the type monetary amount, which is the interface of money that money implements. There are two methods, serialize and deserialize. In this case, we actually want to create a JSON object. So I can work here with an encoder, take the type is the monetary amount, and then create a key currency, put the currency value into that field, and then I create another key amount and put the big decimal in it. Let's restart it. Voila, now we have a list with one bank account with a balance of 0. And again, I'm not sure if the previous, I was mistaken, and the previous error we had was something different. But if I remove this annotation and jump back onto here, we get this error, which I mentioned that this is actually a good thing because you are in control what is serializable and what not. So back onto this one, it's now okay. So let's continue with this. As a good developer, we probably want to test the application, and initially Micronaut Launch provides us a simple test that if we run it, it simply checks whether the application is running or not. So as mentioned, this is a JUnit test, so let's get rid of all that stuff. What I want to do is I want to write a simple test, public void initially there is one account. Okay. So now, how are we gonna get this account? Micronaut has a very nice feature called declarative HTTP client, and in the test section I'm gonna create now this class called account client, and this is an interface. Okay, this interface is annotated with client, and it has the same path as our controller. For the sake of the speed, let's go here and copy this part, jump back, introduce this method, and get rid of the public modifier here. Okay, so we have now an account client that can list the accounts. So let's jump into the test. In Java 5 or with Micronaut test, you have the possibility to inject beans into your test methods. So this is what I'm gonna do here. Is I'm gonna inject the client, and I'm gonna call list accounts. With list accounts, I then assert them to. Let's go with a simple one, just to find out whether it's working or not. So here we go. Oh, there's a test annotation missing. Sorry about that. And boom. Text error, which is also very nice. Remember, in the record here, I said it's certable, but it's only serializable. Again, we're in full control what type can be handled by the JSON framework in what way. So simply use certable if you want to have a two-way thing, serialization and deserialization. And if we now run it, bam, test is successful. Perfect. So let's continue. Maybe we'll start with a post. Create account. So if we now want to hand over a new account, and we leave the ID generation for now to the client. So we simply end in account here, and we put it to our store. Simple thing that could possibly work, but it's of course nothing you should do in production. So perfect. We have implemented the thing. So let's jump into our test world. Public void create account. Account, can I write? Account client. So now this starts to being repetitive. So maybe the other way is if you use this more often in several methods, you have the possibility to inject it, and then you have to inject it in every test method. So of course we need to create this one on our client. So here we go. I will show you then in the end of the tutorial how to get rid of this duplication here. But for now, we're going to continue with create account, new account, UUID, random UUID, and let's say this account starts with $10. And then if we then list the accounts, we expect 2 of them, since we know initially there is 1. Okay. So let's go and try this. Bam, doesn't work. Excellent. Expected 1. Holy cow. Now understand what's going wrong here. The test is a bit silly implemented. It depends on order. For now, let's simply change this assertion here. Assert true. Let's say that assert true. Let's simply say that the size or is not empty. This should do the job. Yes. So as you can see, we have now 2 of them. And for now, why not implement now the delete part? So you get the idea. We simply annotate this one here with the delete method. And for now, we say, hey, delete requires an ID. So we put this ID path variable into the path. And then we create delete method that takes a path variable, UUID, ID. Let's format it and simply remove ID. Here we go. That's it, that's it. So, for example, if we were to, yep, that works. If Micronaut has a very nice feature, this everything happens actually at compile time. So if I were to call this guy here identifier, oops, it's not IntelliJ is too smart. If I were to call this identifier, but in the path variable is called ID, Micronaut will complain. It will tell me, hey, your root has a variable called ID, but your implementation, your method, doesn't. So this is a very nice feature that helps you detect problems before runtime. If we type it that way, everything works as expected. Again, I need to copy this for now and put it here. Get rid of the public modifier. And well, let's just extend this one, create and delete. Let's simply pick one of the accounts and delete it. So we're gonna go and say account, client, delete accounts. That's now a collection. Stream, find any, get ID. Okay. Here we go. We simply delete one of them. And then again, we're gonna go read the accounts and make sure that there's only one. Ta-da! So this is the first round trip about creating a simple REST API and testing it with Micronaut test, which I think is pretty neat. So what are your thoughts? Maybe put it into the comments, and I'm looking forward to read them. In the next step, Micronaut can run as in a Docker container. So let's maybe jump onto that and see how to create a Docker container. Docker image, sorry about that. The first thing, there are two variants to do it. You can either put your FatJar into a Docker image and run it then. This is perfectly fine. Works as a jar, but produces larger images and consumes also a bit more of RAM. So, well, let's first have a look how to do that. It's a bit a pity the default thing. So if we were to create a Docker file, you can do this by running the Gradle task Docker file. The default implementation uses OpenJDK 19, and this Docker image is only available for AMD 64 architectures. I'm running on a Mac, on a Silicon Mac, so this doesn't work for me. But luckily, we can work around this and simply adjust the Gradle task Docker file, and I'm gonna use the Azul Zulu OpenJDK image 21, so the JDK 21, but I will only require the Java runtime environment, so the image then is a bit smaller. And as you can see, if I rerun it, jump to the Docker file, we now adjusted the thing here. And if I then do a Docker build, it creates a brand new image, which will be available here. As you can see, this was created 11 seconds ago. So in order to run it, you can use Docker run. Mount, as mentioned, the application runs on port 8080. So we simply mount expose the port on our local machine and then do this. And as you can see, it started too quickly. No. This was a bit too quick. Sorry about that. Docker build. Let's double check it. Docker image. Here we go. Docker run. Ah, sorry, my bad. Now I see. I started the wrong image. Test. Now, you see the simple application started as a FatJar in our container and took around half a second. Now, we also have the possibility to compile our Micronaut application as a native image using Graal. And for that, let's have a look at Docker file, how the Docker file looks like, because we have the same issue there. This one also uses Alpine, which only works on AMD 64 architecture. So let's adjust this one slightly. And I'm going to use Ubuntu for that. So if we then build Dockerfile native, have a look at the Dockerfile native thingy, we can see that it exposes that it uses Ubuntu 23.10. And I just noticed that this is a duplication here, so let's run this thing by docker build native. Docker build native. Here we go. This will take a while because it compiles it to native code. So we'll see us in a minute when this is done. Okay, so the image has been created. It took around 2 minutes to build it because the application is small. Expect longer build times for larger applications, but let's check. As you can see, 30 seconds ago, and the image is a bit smaller than it was before. But have a look at the startup time now. So we had half a minute, a second before. Now, what happens if we run this guy? It has the same tag, so bam, 23 milliseconds. And the good thing here is, let's run it and then jump into a new tab. If we're gonna go with Docker stats, what's very nice about this thing is it only takes 17 megabytes. If we run it as a FatJar, it will most likely consume at least 5 times more. Let's check if this works. Here we go. It's there. It responses, nothing else is running, so just to prove that I'm not lying here, if I run this one here, connection diffused. So with these simple steps, you can create quite a performant Docker image with your REST API that doesn't consume much RAM and has a blazing fast startup time. So I hope you like this first tutorial. Sorry for the small hiccups in between. I'm doing this the first time, but I hope you enjoyed it, and see you in my next tutorial.